Okay, it's 5:18. We're in the afternoon now. This is video number 88. I'm writing perfect square trinomial there, and this is just a follow-up of what I talked about this morning. And I'm going to take my time solving this problem. It's a multiple choice problem, and we used to do a lot of them together. I'm sure you remember that. So I'm going to work this out one by one to come up with the correct answer, and this allows me to talk more about how you spot a perfect square trinomial, or what we're talking about. So I'm going to go back and just do one that we did this morning. Let it be 2x minus 3 squared, and we agreed that it's 2x squared, which is 4x squared, and plus, because a negative times a negative is a positive, and then this times 2. So this times this times 2, and then of course the x always tags along. And so the pattern was, this must be a perfect square. This must be a perfect square. And then it's 2 times the product of the numbers that you're squaring there. And let me move this over a little bit so you can see what I did clearly. And I'll pause for a second because I haven't gotten to the question yet. So there we go. And when I write it all out, I got 4x squared plus 9 minus 12x. And I put it into standard form, and these are the kind of things I'm looking for. Notice if I put a plus here, the answer would just be adding the two together. Now, tomorrow I'm going to go over the general rule, write it out, and apply it to numbers. But you need to see that. So now we're going to see can we get from here back to here. It's called factoring, but we don't need factoring skills to do this. We just need a little bit of common sense. Notice right away the square root of 4 is 2, and the square root of 9 is 3. Perfect squares, I say that word again. I'm going to use that to determine which one is a perfect square trinomial, and from there I'm actually going to tell you exactly what it is and draw a picture of it. So let's go here. And with that little reiteration of what I told you before, now I'm going to just quickly draw it here. Okay. Now I'm going to decide which are true and which are false. So we agree you're either a perfect square trinomial or you're not. You either are or you aren't. Usually in math that's very common. So A can't be the case, and normally I'd call on the class and say, who wants to tell me why? Well, you could start with the most obvious thing, in the history of the universe. How about that? 8 is not a perfect square. So how can this be a perfect square trinomial? Square root of 8 is this, and we got really clever before where we simplified it to that. So whatever it is, whatever beast, it's a quadratic trinomial, all right? But whatever else it is, whatever other knowledge we'll have about it, has nothing to do with perfect square trinomials. So that eliminates A. And now I go on to B, and I start out good. The square root of 16 is 4, so I'm good there. And the square root of 9, that's another perfect square, is 3. And so 4 times 3 times 2 is 14. So it could be negative, but it could never be 12 for the math that we know. So let me go over that again. I took the square root of 16, which is 4. That's cool. Square root of 9, which is 3, perfect squares. And I doubled it just like I did before. But this is 24, not 12. Excuse, I might have said 14. This is 24, not 12. Or negative 24. But whatever it is, it's not a perfect square trinomial. And I'm going to erase this now because I just put those ideas there. And I know how weak students get confused with too many symbols. So this, because it's not negative 24 or positive 24, cannot be a perfect square trinomial. What is it? I don't know. We'll talk about that. That's part of the math that we have to do in high school. I go to the third guy, and the first term's a perfect square trinomial, so that's good. The second term's a perfect square trinomial. So it's just like the last one. So the middle term has to be 2 times 3, and of course we just double that. And so instead of 12, they wrote 6. So this can't be a perfect square trinomial either. So the last one is, let's determine why. Let's see, 4 and 25 fulfill our criteria. You agree, right? They're perfect squares. And the square root of 4 is 2. And the square root of 25 is 5. And I double that, and I get 20. Oh, okay, so this seems to be handling all the, there's an X here, sort of tagging along, if you know what I'm talking about. So we say, oh, wow, that's kind of okay. That does fulfill our criteria. The first term's a perfect square, the third term's a perfect square, and double their product is matches the middle term. So now the question comes up, and that's where you're going in high school. That's the whole name of the game, basically, comes up. So what is it? Well, it's a perfect square trinomial, so we can start with saying it's the area of a square. Agreed? I don't think anybody who's been paying attention to me would deny that. So it is the area of a square. So what's the side? That would be the question. And that's just a natural question to ask. And we can do that easily without, it's called factoring, but we don't even have to call it that at this point in time. Since the square root of 4 is 2, and it's x squared, I'll definitely be multiplying 2x times 2x. You can't deny that. It's so obvious. And since the square root of 5 is 5, 25 is 5, then I have to be multiplying for the last term in this so-called FOIL game, 25. Well, 2 times 5 is 10, 5 times 2 is 10. Add them together, I figured out the side. And this is really this. And that ought to interest some people at least. And even if it doesn't interest you, it certainly gives you a good picture of where you're going. So these guys, we've yet to discover what they are, if they're anything. But letter D is a perfect square trinomial. It's the area of this square where it's 2 times some number that we imagine in our heads. Probably we wouldn't want this side to, it could be negative because a negative times a negative is a positive. So it's some number that we imagine. I don't see any problem with restrictions. And, well, maybe if you say a side is negative, okay. But squared, there's certainly no restrictions. And so anyway, there's the picture, there's the correct answer, and I want to go back to these ideas and give you some more work on this. All right? So the correct answer, of course, is D. It's a square, and the side of the square is 2x plus 5, and we went from here to here for the first time. You should think about me doing that. Just think about that. Okay.